This is the lesson for Chapter 3, Section 6, titled Compound Inequalities. And on this one, we're going to be dealing with two different types of statements. We're dealing with an AND statement and an OR statement. And so an AND statement is going to end up being when we end up seeing values that are between. So when we see that word between, that tells us that we're dealing with AND statements. We're also going to see that when we have an expression like this one over here, where we've got the variable k in between two numbers. So we'll see that. And so when we have an OR statement, OR statements are ones that are opposed to one another. And so we'll see an OR statement where we've got values not between, but opposite one another. And so we'll see that situation as well. So let's take a look at this first problem. It says all real numbers are less than -3. So if I write that, x is less than -3. So these numbers are less than -3, or they are greater than or equal to 5. So this is the statement I've got. So it says it's an OR statement because the values are either going to be less than a smaller number or greater than a bigger one. And when I go ahead and plot this, I got -3 here, 5 here, and it's an open circle on the -3 going to the left. So this way you can visualize where those solutions are a little better, because when I look at this one, it says x is greater than or equal to 5. So you can see OR statements typically are opposite one another. They're working against. They're not going in the same, they're not working towards each other, typically is what we're going to end up seeing. We'll see one on this next example down here where they do kind of work in towards each other, but we'll talk about what those solutions mean. So OR statement means it works with one inequality or the other. It doesn't have to work with both, is what we've got. Time it takes to take or bake a cake is between. So between is the key word there that tells us that we're dealing with and. And so it's in between 25 and 30 minutes. Inclusive. Inclusive means it includes the values of 25 and 30. And that's important. That means we're going to use the equal to symbol. So we're going to set them up this way. 25 and then 30, and since it's between, we're going to show the value of x in between. Now, how do we set up the inequality signs to match it? Well, it's between these two numbers, so x has to be greater than or equal to 25. See, x is greater than or equal to 25, but less than or equal to 30. And that's the way we're going to set these up. So when we go ahead and graph that, 25 is here, 30 is here. Close circles because it's inclusive, and it's in between. The values of x are bigger than 25, but less than 30. So those are the two different types that we're going to see. Let's take a look at some different examples. Now, this one's a little different. It's an OR statement because it says it is right here. So we know it's going to be something like this where the values work with one or the other, but not necessarily both. So if I go ahead and solve this, I've got 6b is less than or equal to 41. And when I go ahead, actually 42, let's change that, 42. And then over here, I have to subtract the 1 from all sides. So I have or 2b is greater than or equal to 10. So when I go ahead and solve this, I'm going to divide by 6, and I get b is less than or equal to 7. Over here, I get b is greater than or equal to 5 when I divide by the 2. So I go ahead and set this up. So I've got my solution here. Let's take a look at our answer. So when we go ahead and do this, we've got 7 on one side of the inequality, 5 on the other, and then just graph them separately. b is less than or equal to. Less than or equal to. So remember, when it's an OR statement, it just means it has to work with one inequality. So the values of x are going to be in this direction. But on this one, it says b is greater than or equal to the 5. So it goes in this direction. So notice that it has to work with one, the values of b work with one or the other. Doesn't have to work with both. Because it's OR, it's just working with one or the other. So you see how the values of x are greater than 5 but less than 7. So this would be all real numbers. Are going to end up being solutions in this case because they work with one or the other, and they're going towards each other and going past the 7 and past the 5 up to the left. So set builder notation would look like this: all values of x such that x is all real numbers with braces in between, or braces around. So on this one, this is an AND statement. It's an AND statement because the value of k is between two numbers. So let's see what this one looks like. So if I go ahead and multiply by 4, and so I end up with this: 12 is greater than 11 plus k, which is greater than or equal to negative 12. All right, so I go ahead and solve a little further. I subtract the 11 from all sides, and I end up with 1 is greater than k, which is greater than or equal to negative 23. So I know this is an AND statement because they didn't say it was an OR. And when I go ahead and set this one up, I've got negative 23 over here, I've got positive 1 over here, and the values of k are greater than or equal to the negative 23, but less than the positive 1. So they're between the numbers in this case here. So let's take a look at some other problems that we might end up seeing. Let's try these two. So on this one here, we see this is going to end up being an AND statement. An AND statement, the values of p are in between. So we go ahead and add the 3 to all sides. So when I do that, I've got 6 is less than 2p, which is less than or equal to 15. So when I divide by 2, I end up getting 3, which is less than p, which is less than or equal to 7.5. So when I go ahead and draw this out, I got 3 and 7.5, and I've got an open circle on the 3 but closed on the 7.5 because it includes that number. It's got the equal to symbol. And the values of p are greater than 3, so going towards the right, but less than, because it points to the p here, less than or equal to the 7 5/10. So looking at this one, I have a little bit more work. Two-step equation here. Notice that it is an OR statement though. So I've got 5z is less than negative 10 when I divide by 5. I've got z is less than negative 2. Notice I did not switch the inequality sign because I divided by a positive. Where on this one, when I go ahead and do it, I've got negative 2z is greater than negative 6 when I divide by negative 2. Notice this time I do have to switch the inequality sign, so z is less than positive 3. So when I go ahead and graph this, so it's an OR statement they're telling me. So when I go ahead and graph, I got negative 2. The values of z are less than negative 2, or z is less than positive 3. So it goes off in this direction. So the values that work, since it works with one or the other, the values would be z is less than 3. Because the less than negative 2 is included in all of those values for negative z less than negative 2 are included with the values of z is less than 3. Alright, looks like it did make a little error here, so let's go ahead and fix that. So I see that this stage right here I put plus 6, but then I added only 2, so let's go ahead and fix that. Just a small number there, so this is going to end up being 6, so this makes negative 2. So we'll fix that part. So this makes negative 2. This number is going to change, and this will end up becoming a negative 2, and we still divide by the negative 2, which makes a positive 1 this time. So z is just less than 1 is the only solution we need, since it includes all the values of z less than negative 2. So let's take a look at a couple word problems then. And here they are. So it says the absorbent for a certain towel is considered normal if the towel is able to hold between. Okay, between right there, that is the key word that we know we've got an AND statement. So it helps us visualize what's going on. So it's between 6 and 8. So here's 6, here's 8. I know it's between those two. Now, if they use the word inclusive, then we'll go ahead and fill in those circles. So let's see what it says. It says the first checks the material results in absorbent measures 6.2 and 7.2. What possible values for the third reading M will make the average absorbent normal? Alright, so In this case, we don't see the word inclusive, so it's just between these two. So let's go ahead, and we see the first two measurements are 6.2 and 7.2, and they're going to do a third one. So let's find the lower end of it. So we want to add x. We're not sure what that number is yet, but we want it to equal 6 when we go ahead. Actually, we want it to be greater than 6. Greater than 6 when we find that average, because they're asking for what if we find the average of these three. And so when we go ahead and do this, I'm going to multiply this side by 2 and this side by 2, and I'm left with 6 and 2/10 plus 7 and 2/10 plus x is greater than 12. So when I add these two together, it gives me 13 and 4/10 plus x is greater than 12. And I'll subtract that, so I end up with x is greater than, and then I end up getting the difference of 13 and 4/10 from 12. So I see that right here. I made another error. Let's change that. It shouldn't be 2. It needs to end up being 3. So let's go ahead and fix that right there. So it needs to be 3, and the reason is that we've got 3 numbers, not 2. So I multiply by 3, and when I do that, I end up with this. I end up with that 6 and 2/10 plus 7 and 2/10 plus x is greater than 18. And when I add these numbers again, 13.4 and 18 here. So I knew I was doing something wrong because I was getting a negative number when I did that subtraction. So I had to go back and think about it for a minute. And when I subtract those two numbers, remember, you got to borrow a little bit. So that ends up giving me a 6 or 5 and 6/10 is greater than, or x is greater than 5 and 6/10. Or let's see here, it makes 4 and 6/10. I'm messing up all over the place. I guess when you mess up once, you mess up more. So there it is. X is greater than 4 and 6/10. That's a 7 minus 3 makes the 4. All right, so that's kind of the low end there. Let's find out what the high end is. So let's see if I can do a little better this time. 6.2 plus 7.2 plus x over 3, because there's 3 numbers, and this has to be, this time, less than 8. Less than 8. And so when we go ahead and solve this one, I'll multiply by 3, and I'm left with 6 and 2/10 plus 7 and 2/10 plus x is less than 24. So again, I'm getting that 13 and 4/10 plus x is less than 24. So when I subtract those two numbers, that's going to end up giving me 10 and 6/10. So 10 and 6/10 is greater than x. All right, so here are my two numbers, and since it's between, this is the way we'll write it. We'll say 4 and 6/10. The third value must be in between 4 and 6/10 and 10 and 6/10. So the values of x need to be greater than 4 and 6/10, but less than 10 and 6/10. And that's the way we'll end up writing it there. And again, notice that did not use that word inclusive, so we did not include those two values. Let's take a look at the last one here. It says a family is comparing different car seats. One car seat is designed for a child up to and including 30 pounds. So we'll say the car seat is up to, which means not equal, not bigger than 30, but less than 30, but equal to. So that would just end up looking like this. Here's 30, here's 29, and so it includes that number, but it is smaller. And then the next one, another car seat is between. So between means that it's between 15 and 40, and it doesn't include those two numbers because it doesn't say it does. So x has to be greater than 15, but less than 40. So we'll go ahead and write that in there. There's 15, there's 40, and open circles on those because it doesn't include those numbers, but between those numbers. Now the third car seat is designed for a child between, again, so between 30 and 85, inclusive. So this time we do include those numbers, so we're using that inequality sign with the greater than or equal to and less than or equal to. So since it includes it, we've got 30 here and 85 here. Including means a solid circle, and it's in between those two numbers. So which would be appropriate? Well, for a 30-pound child, I wouldn't go with the first, because he'll end up just meeting that, and then you'll end up not being able to use it once the child gains some weight. So I would go with either the second or third would end up being the better bet. So those are the types that you're going to end up seeing on tonight's homework. Good luck.